So in this video we'll check out number 3 from the 2013 A, B, and BC exam. And in this piece of number 3 it wants us to try and figure out whether or not there needs to be a t-value between 2 and 4 where c prime of t equals 2, and then justify your answer. Well, anytime you see something like this and it says does there have to be something that equals this value, it's going to really involve one of two things. Either the mean value theorem, which guarantees the value of a derivative given certain conditions, or the intermediate value theorem, which guarantees the value of a function given certain conditions. Since this says, is there a point where c prime of t has to equal 2, I have the mean value theorem over here, and we'll just kind of recall what this says. So I'll enlarge this, we'll talk about it for a minute, and then we'll make use of it. So mean value theorem said if you have a function that's continuous on a closed interval and differentiable on that open interval, there has to be some number in between the endpoints of that interval such that the derivative evaluated at that number is equal to the average rate of change of the function on that interval. So at the end of the mean value theorem we have this statement that says the derivative of something has to equal something else. That's basically what we're asked to show here. So I think we're going to try to make use of the mean value theorem. Now in order to use what we just discussed for a few seconds, we have to make sure that the function we're trying to apply this to is two things, continuous and differentiable. So is our function continuous? Let's start with this actually. Is it differentiable? Well, it flat out tells us in the problem statement that our function's differentiable. The amount of coffee in the cup is given by the differentiable function c. So yes, our function's differentiable. Now there's this little result that you probably remember looking at some point that said if the function's differentiable, differentiability implies continuity. So if differentiable, that implies that it has to be continuous as well. So the problem doesn't really come out and flat out tell us that it's continuous, but it does say that we're differentiable, and if we're differentiable, we've got to be continuous. So given that these two conditions are true for the function c, we have a green light to go ahead and proceed with the mean value theorem here. And what we want to try to do is apply the mean value theorem to the function c on the interval from 2 to 4. So we're going to try to really compute what we have right here within the mean value theorem, this average rate of change. So we're going to compute f of 4 minus f of 2 over 4 minus 2, and that average rate of change is going to be f of 4, which is 12.8, minus f of 2, which is 8.8, just taking those numbers right from out of the table, right? I said f of 2 and f of 4, it's really c of 4, right? C of 4 is 12.8, c of 2 is 8.8, and then that's going to be over 4 minus 2. And if you go ahead and simplify, 12.8 minus 8.8 is giving you a 4. In the denominator you're looking at a 2. The average rate of change of c on the interval from 2 to 4 is 2. Since the function is continuous and differentiable on the interval 2 to 4, we can apply the conclusion of the mean value theorem. So by the mean value theorem, yes, we're guaranteed there's going to be a point between 2 and 4 at which the derivative of this function c equals 2. So I know I didn't really write out a conclusion or a justification here. I wrote out the most important details. I verbally stated everything. On your AP exam, you just want to make sure that you kind of paraphrase what I just verbally stated onto your page.